Hello and welcome to part 2 of the EAP series brought to you by Tackleist.com. In this video, we're going to be talking about the one particular type of EAP known as EAP FAST. In the previous video, if you watched it earlier, and if you haven't watched it, I strongly encourage you to go ahead and watch it on the YouTube channel, which I'll specify at the end of the video. And in that video, we had talked about what EAP was all about, what are the different types of EAP, and we had left the video without talking about EAP FAST. I promised you that I'd be making another video where we're going to be exclusively talking about EAP FAST because this is kind of interesting and it's a little awesome on its own. So let's get started and have a look at what we're going to be basically doing in this video. I know this is a funny looking slide, but I have a reason for putting this here. I'm sure most of you would have watched the hit TV series Roadrunner, or I'm not too sure what it was called actually, but one of the characters in that cartoon series was this bird called Roadrunner, and it was known to be exceedingly fast, and the coyote couldn't catch that, or coyote. I guess that's how you pronounce it. I'm sorry about that. The Roadrunner was exceedingly fast, and that's why I put this here. When you hear the term EAP FAST, I don't want anyone out there to confuse yourself by thinking this is a faster authentication protocol when compared to other EAP methods. I agree that this could be faster than some of the protocols out there, but this is definitely not the fastest. The name FAST comes from flexible authentication via secure tunneling. The name FAST is just an acronym for this big word which Cisco developed. Although it kind of sounds like it's faster than other protocols, that's the magic of Cisco marketing. So with that introduction and with a little picture of what we're basically going to be talking about in this video, let's get started and have a look at the contents of this video. In this video, we're going to be talking about what EAP FAST is all about. Why do we need EAP FAST? Then, we're going to be talking about a mysterious term known as PAC or PAC, and why do we need it, especially in EAP FAST. Then, we're going to be diving a little more deeper into EAP FAST and having a look at the different phases of EAP FAST operation. Then, we're going to be diving a little more deeper and have a look at the EAP FAST message exchange, which by now you would already know is one of my favorite parts. Then finally, we end on a kind of unhappy note and we talk about the different issues with EAP FAST. So let's get started and have a look at our first topic. EAP FAST was basically a Cisco proprietary authentication protocol that was developed a while back. And Cisco basically, when it developed it, had a couple of objectives in mind when they did it. One of the objectives that it had in mind was that this protocol should act as a replacement for LEAP. As you already know by now, LEAP was one of those authentication protocols which had a lot of security flaws in it, in the fact that it could easily be cracked. The MSCHAP v2 hashing method that was being used by LEAP could have easily been hacked by either an online or an offline hash attack method using softwares known as ASLEAP. And the other criteria or the other goal that Cisco had when it developed EAP FAST was for EAP FAST to be as secure as PEEP. As you all know, PEEP is an authentication protocol which is one of the most secure protocols out there. Well, it's not the most secure. The most secure could probably be EAP TLS, but PEEP is a close second where you're going to be using the concept of a tunnel where there's going to be an outer identity, which is going to be a fake identity, and there's going to be the inner identity, which is the actual identity. So PEEP was kind of the goal that Cisco was aiming to reach when it created EAP FAST. Whether it reached or not, you'll get to know when you get to the end of the video. The other fact about EAP FAST is, although this is a new EAP protocol, it kind of still maintains the same structure as other EAP methods. And when I mean structure, if you've already watched the previous video and you know what I'm talking about, the structure is basically the first method where either the supplicant or the authenticator initiate the EAP process. That's the first step. And you have the optional second step where the client authenticates the authentication server. Then you have the mandatory third step where the server authenticates the client. And if everyone is happy, the encryption key exchange takes place, and now the supplicant and the authentication server now have what is known as a master session key, or an MSK. This is basically what we're talking about. This is basically the structure of any EAP method, and EAP FAST also follows the same structure. It could vary a little bit, but we're going to be having a look at where it varies and how it varies. The other thing which I wanted to tell you is EAP FAST also uses the same concept as PEEP, which is basically the EAP within EAP concept, where just like in PEEP, there's going to be an outer identity which could be a fake or an anonymous identity, and there is a tunnel which is created using that outer identity and or using certain other material which we're going to be discussing later, and inside that protected tunnel the client is going to be passing its real identity. So basically the real identity is going to be protected by the tunnel to prevent itself from eavesdroppers or attackers. So since Cisco was aiming for this protocol to be as secure as PEEP, it went ahead and introduced this. It kept the concept of EAP within EAP, just like in PEEP. That rhymes, doesn't it? On that note, let's go to the next point where we're going to be talking about a pack. Let's take a little more examples. If you go back all the way to Leap, we now understand that Leap uses the client username and password combination as the authentication credentials of the client. If you go to some protocol like EAP TLS, the client is going to be having its own X.509 certificate as its authentication credential. That brings us to the question, what is the authentication credential in EAP FAST? The answer to that is that EAP FAST uses what is known as a PAC, or a PAC, as its authentication credential. PAC stands for Protected Access Credential. This is kind of like a username and password combination, and it's also kind of like a certificate. You can call this as a cousin of both the username, password, and the digital certificate. So this is kind of like a mixture of both. It's not as good as the certificates, let me warn you, but it's still better than the username, password credentials. So what are PACs? PACs are nothing but they're shared secrets that are shared between the authentication server and the supplicant. So what a PAC is nothing but the authentication server creates what is known as a PAC for each individual supplicant who is trying to log into the network. It creates this by using the username of the supplicant, or the Windows or any other username of the supplicant, taking that, using its own secret key, which is present only in the authentication server, and running them through an algorithm and creating what is known as a shared secret key. This is known as a shared secret key because both the user and the authentication server share the same secret key. And PAC uses what is known as symmetric encryption. And by this we mean that to encrypt and decrypt the data, the same key is going to be used by both the supplicant and the authentication server. Well, this has its benefits, which I'm going to be talking about later, because using symmetric encryption is definitely faster when compared to using asymmetric encryption, like, for example, when you're creating the tunnel using the certificates presented by the authentication server. So PAC is basically a client identity which is going to be used in order to authenticate the client to the authentication server. Now, the other thing which I wanted to talk to you about is the different components of a PAC. When the authentication server sends the PAC over to the client, a PAC consists of different things. So let's have a look at what a PAC consists of. Any PAC which is sent to a user has three basic components. The first component is the pack key, or this is going to be the shared secret key. This is the actual key which is going to be used for encrypting communication between the client and the authentication server. Then we have what is known as pack opaque, or this could be said as the client identity. This is the part of the pack which identifies the client to the authentication server. And finally, just like in digital certificates, we have what is known as the issuer identity, or in this case, this is the identity of the authentication server, and that information is stored as the pack info. One thing I want to tell you is every user who is trying to log into the network should and must be allocated a pack. There might be 5 users trying to use the same laptop to connect to the wireless LAN. So what is completely essential is that the laptop now has to store 5 different packs for each individual user. So 5 users need 1 pack each. And this is very important. You can't have a pack for a machine alone. You need a pack for every individual user. One more info that is kind of important is the pack info field in the pack which is sent to the client also has what is known as a pack lifetime. So this pack which is sent by the authentication server to the supplicant has a certain lifetime, after which the pack needs to be renewed by the authentication server. All right, now that we have understood what a pack is and what are the different components of a pack, let's have a look at something a little more interesting. We've now found out that the authentication server creates the pack. So let's go to the next step where we figure out how the authentication server, after creating the pack, how does it send it over to the client? Or how does it send it over to the supplicant? In order to send this, there are 2 methods. One is the manual method, where after the authentication server generates the pack, the administrator has to go and manually import that particular pack into the supplicant software. For example, if the supplicant is running the AirNet desktop utility as its supplicant software, there is a procedure where you can go into the GUI of AirNet desktop utility and import a pack. So this is kind of a time-consuming process because it's going to take a lot of time. Imagine you have a network where there are 100 or 1,000 users trying to log into the network. So basically what the administrator has to do if the model being used is manual is that the administrator has to go to each and every laptop and manually issue and import a pack and install it on the client. Isn't that really hard? So that's why they came up with the other method of pack provisioning known as the automatic method. I know what you're thinking. Automatic method seems awesome, right? So basically it's what it says it is. Automatic method is where a new pack user and the authentication server don't need to intervene in the entire pack provisioning process. As long as they're both enabled to support automatic pack provisioning, they're going to go ahead and automatically exchange credentials with one another, establish some kind of encryption mechanism, and the authentication server is going to shoot the pack over to the client, and everyone is happy. This all happens without any intervention, and the automatic method can be used for large-scale deployments. Let's have a look at what are the different components of an automatic exchange. Now that we've understood the different types of pack provisioning, let's dive a little more deeper into automatic pack provisioning and have a look at what really happens in automatic pack provisioning. The first step that happens in automatic pack provisioning is the supplicant and the authentication server perform an MSCHAP v2 exchange. Using this MSCHAP v2 exchange, the authentication server now gets the username, if I can spell this right, of this client, and it uses this username along with a secret value that it has in its own say hard disk, and it's going to create the shared secret key. Now here's my issue. after the authentication server creates the shared secret key, or after it creates the pack, is it going to just blindly send this over in clear text over to the client? No, because if there is any eavesdropper, that person can get his or her hands on the pack when it's being transmitted. So what the authentication server does is it's going to use Diffie-Hellman method in order to set up a temporary encryption channel between itself and the client, and through this channel, it's going to send the pack over to the client. So again, although this seems like a very foolproof method of automatic pack provisioning, this has its own risks to it. Automatic pack provisioning opens itself to a lot of attacks like man-in-the-middle attacks and MS-CHAP cracking using the AS-Leap software. MS-CHAP v2 is the same algorithm which is used in, say, Leap, and where this can be easily exploited using AS-Leap. So that opens itself to a vulnerability because the client's credentials can now be procured by any attacker running AS-Leap during the pack provisioning process. And it also opens up an awesome attack known as the man-in-the-middle attack, which I'm going to stop now and I'm going to talk about that later. Well, just one side note, if you're all wondering what Diffie-Hellman encryption is all about, I strongly encourage you to learn about it because it's one of those great protocols which was invented, and it's used basically in most places where there's encryption or VPNs, and it's also used in IPsec VPNs which are designed, and it's a great method to establish a secure protected channel between two clients who don't have any knowledge about each other, and this is used to establish a secure tunnel over an unencrypted communications channel. So with that said and done, and now that we've had a look at the different types of pack provisioning, let's have a look at what Cisco, or one of the biggest players in the networking industry, recommends with respect to the two different types of pack provisioning. Cisco recommends that when you're bringing up a network and you have a lot of supplicants and you have basically a large network, it's kind of prudent to use automatic pack provisioning initially. Because if you're going to be using manual pack provisioning, it could be very labor intensive, and it's basically, and it could induce a lot of man-made errors and a whole lot of different complications which are not essential. But after finishing the automatic pack provisioning, Cisco recommends that you move over to manual pack provisioning because as the number of clients keep adding on, it's much more easier to go ahead and manually install the pack, because keeping the automatic pack provisioning feature on for a long time opens up the system to a lot of attacks. So basically what Cisco is saying is try and do automatic pack provisioning when it's absolutely necessary to do it. Otherwise, shift to manual pack provisioning. That's what Cisco says. So now that we've had a look at what pack is all about, the different types of provisioning, and what the Cisco recommendations are, let's dive a little more deeper into the EAP FAST method. EAP FAST, again, as I said, has different phases. Different phases are nothing but different steps in the entire EAP FAST negotiation process. The EAP FAST can basically be divided into two mandatory steps, that is phase 1 and phase 2, and one optional step known as the pack provisioning step. Let's look at step by step. The pack provisioning step is basically a step which is done only once. This is very, very important, and I wanted to remember this because pack provisioning is done in order to give the supplicant the pack. So the authentication server is going to create the pack and send it over to the supplicant. How are we going to do it? We can do it either manually, as we discussed earlier, or using automatic pack provisioning. And this method of automatic pack provisioning is known as phase 0. I know this kind of terminology can come only into picture when you're talking about computing terms where there is a phase 0. Essentially, this should have been phase 1. But since this is earlier than phase 1, they've gone ahead and coined this phase 0. Remember, either way, pack provisioning happens only once. The next method is known as the phase 1 method, where just like in normal EAP, if you're looking at PEEP, the first kind of step is to establish the tunnel using which the inner methods are going to be, inner authentication protocol is going to execute. So the first method is going to basically exchange dummy credentials just like PEEP, and it's going to set up a TLS tunnel just like PEEP. So phase 1 is very familiar to you, and phase 2 is also exactly like EAP TTLS or EAP, where inside the secure tunnel, the actual supplicant credentials are exchanged. So phase 1 and phase 2 are very common, are the same as say EAP or EAP TTLS, but the only difference here is the optional phase 0, which is the automatic pack provisioning, which only happens once, or the manual pack provisioning, which also only happens once. Now to our favorite part. Let's go ahead and have a look at the EAP FAST message exchange and decipher this. As again, I've already told you, although this looks kind of daunting from a high level point of view, if you dive deeper and break this down into different sections, it's going to be a piece of cake. So let's get started and have a look at this. When EAP starts, the supplicant is not happy, the authenticator is not happy, and it's an uncontrolled port. So basically no other messages except the EAP messages are allowed to pass through this port. So what happens next is the supplicant sends over the EAP start. So if you look at my previous videos, I break this down into different steps. So the different steps here are, first, this is the supplicant trying to start the EAP process. This basically jumpstarts the EAP process, this whole step here, and at this step, after the client sends its anonymous or bogus username to the authenticator along with the EAP type specified as EAP FAST, this method goes to the authentication server here, and the authentication server decides, hey, there is a supplicant out there and he or she wants to authenticate to me using EAP FAST. So what the server is now going to do is it is going to send its pack, or the server is going to send or request for the supplicant's pack here. What the server does is it sends an EAP FAST start message, and the supplicant sends over its pack. This pack is basically sent to the authentication server. The authentication server authenticates that this is actually the client that it's talking to by using the pack opaque field present in the client pack. If you can recall, the pack consists of a shared secret key, the pack opaque field, and the pack ID field. The pack opaque field is the client identification. So when the server receives the client pack, it authenticates that this is actually the server that it's supplicant that it's talking to, and using the shared secret key present in the client pack, it is going to establish the TLS tunnel. Now here's the difference. If you're thinking about different methods like PEEP, where the authentication server is basically going to be using its certificate, or the authentication server is going to be using its certificate data in order to set up the EAP TLS tunnel. EAP TLS tunnel, this tunnel is going to be operating on an asymmetric encryption basis if you're looking at EAP PEEP or EAP TTLS. But in the case of EAP FAST, this is going to be done using symmetric encryption. And symmetric encryption brings about a small speed difference between EAP FAST and EAP TLS and gives EAP FAST a little advantage. Not too much of an advantage, but a little advantage, or it makes it a little faster than EAP TLS, EAP TTLS or EAP PEEP for that matter. So now that we have set up the encrypted or the initial tunnel, let's go ahead and go to phase 2. This whole step here was phase 1, which included setting up the tunnel. Phase 2 here is basically where EAP PEEP supports, let me just tell this to you. EAP FAST supports many different type of inner authentication protocols. You can have, say, EAP MSCHAP, you can have EAP FAST, you can have EAP TLS, you can have EAP PEEP even running inside EAP. It's very similar to EAP TTLS, where you can have a varied combination of inner authentication protocols. In this particular example, we're going to be using EAP GTC as our inner authentication protocol. One more time, I want to tell you, the inner authentication protocol could be any EAP method. But in this example, we're using EAP GTC. Another note I want to tell you this, and I found this interesting. When I was going through the Cisco documentation, it says that EAP GTC is the only inner authentication method supported by the Cisco ACS line, or ACS is the Cisco's proprietary authentication server. So if you're using a Cisco only network, and if you're using the Cisco ACS as the authentication server, you need to only use EAP GTC as the inner authentication method. Now, in the inner authentication method, the authentication server requests the supplicant for its GTC credentials, and the supplicant sends over its real username as the EAP GTC credential over to the authentication server, and where the authentication server validates the credentials, and if this is a success, the EAP becomes the authenticator sends over an EAP success over to the supplicant, and after which the encryption keys are negotiated, and the port becomes an uncontrolled port at this point. Oh, I think I made a mistake by saying that this port is an uncontrolled port. Before the EAP exchange takes place, this port is actually a controlled port, and after which it becomes an uncontrolled port. So now that we've broken down the EAP FAST method and we've had a look at the different sections of EAP, the different phases of EAP FAST, and the different message exchanges that take place during EAP FAST, let's dive a little more deeper and have a look at the different issues with implementing EAP FAST in your network. One of the issues is that EAP Phase 0 has some problems. If you can recall, EAP FAST Phase 0 is nothing but the automatic pack provisioning phase, where this only happens once, and the authentication server and the supplicant automatically negotiate information, and the client pack is sent over to the supplicant. Now, this process brings about a lot of security flaws, and the first thing is that the MSCHAP v2 algorithm, which is used to exchange the credentials between the authentication server and the supplicant, is inherently weak and can be cracked by an attacker. The MSCHAP v2 packets can be accumulated, and it can be run as an offline attack using ASLeap, and now the attacker can get the client username and password, and he or she can happily crack or get into the wireless LAN. So this is an inherent weakness in EAP phase, or in EAP FAST Phase 0. The next, or the more dangerous security flaw with EAP Phase 0 is that it is susceptible to the man-in-the-middle attack. In the beginning of EAP Phase 0, or EAP FAST Phase 0 to be more precise, the client sends over its credentials over to the authentication server. If you remember MSCHAP v2 algorithm, when the authentication server requests for client information, before the client authenticates the server sends over its username and password over to the server, and then it does the server authentication. So basically, if there is an attacker who is posing as the authentication server, the attacker can get the client credentials during the Phase 0, and after which the client would detect that the server is basically an attacker, and it would tear down the connection. But before it tore down the connection, it has already gone ahead and sent its information to the authentication server. So basically now the attacker, posing as the man in the middle, has the client credentials. Even though the EAP FAST process didn't happen, the client credentials are now sitting with the attacker. So these are the two kind of like major security flaws with the automatic pack provisioning which is present with EAP FAST. That's why Cisco recommends that you use EAP FAST automatic provisioning as minimally as possible. So now let's have a look at what are the competitions to EAP FAST, or how does this fare when compared to older authentication protocols which were also weak. if you remember Leap, when we're talking about Leap, this same MSCHAP v2 problems came up there. So you can think, is this still going to be better than Leap? Because I see the same security flaws here. Well, it is still kind of better than Leap because although the security flaw is there with MSCHAP v2 running, it's there with phase 0 running MSCHAP v2 and phase 0 being susceptible man in the middle, it's only going to be susceptible once. Or the window for opportunity is kind of less because EAP phase 0 only happens once at the beginning or when a new supplicant joins the network. So after that, EAP phase 0 never happens, MSCHAP v2 exchange never happens, so it is kind of secure after that point onwards. So EAP phase 0, since it's only done once, it's kind of still more secure than Leap, where in Leap, anytime any client authenticates to the network, whether it's the first time the client is authenticating or say the 100th billionth time, it is still susceptible to the AS Leap attack and the username credentials can still be procured in Leap. And the second issue or the second reason why EAP FAST is a little more secure than Leap is because when during EAP FAST authentication, if the attacker is going to be posing as the man in the middle, or if the attacker is posing as the rogue authentication server, the attacker is basically revealed, and this opens him or her up for detection. Whereas in Leap, the attacker does not have to reveal himself. All the attacker needs to do is grab the packets off the air and run an offline attack against them. And voila, the attacker can now get the username and credentials. So these are the two reasons why I would still recommend EAP FAST when compared to Leap. There's absolutely no reason you should still be using Leap on your network, except for demonstration purposes. But one thing I want to tell you is Cisco didn't meet its second goal where it designed EAP FAST to be as secure as PEEP. EAP FAST can never be as secure as PEEP or EAP TLS or EAP TTLS because PEEP, EAP TLS, and EAP TTLS have an inherently secure architecture where they use the PKI infrastructure or the private key infrastructure or public key infrastructure, whatever you call it, and that's going to be used using certificates. So inherently PEEP, EAP TLS, and EAP TTLS are way more secure because it's very, very or incredibly hard or maybe even impossible to act as a rogue authentication server, or it's very impossible to act as a man in the middle in those three different types of EAP. Another issue with EAP FAST is that although this is not an issue these days, if you're looking at legacy hardware, you must check if the hardware supports EAP FAST because EAP FAST was developed a little later in the timeline. So if you have legacy hardware supporting older authentication methods like Leap, PEEP, EAP TLS and stuff, you should check it if it supports EAP FAST. That's one of the issues. And if you're looking at a wide network where you have hundreds and thousands of clients, this could be an issue where some clients just can't get on the network because their adapters don't support EAP FAST. And if you're going to saying, I see that EAP FAST phase 0 or automatic pack provisioning has so many security flaws that I'm going to just do away with it and just go and do manual provisioning. Well, the downside to that is it's very labor intensive. And it's going to take a toll on the number of hours that you need to spend setting up and provisioning the wireless network. So that's something you need to watch out for if you're going to be opting for manual provisioning. Judging by all this, I remember, if you recall my previous video, I was saying that EAP TLS implementation could be a pain in the rear because of all the client certificates out there. Each client needs to get a certificate when it joins the network and stuff. But still, compared to manual provisioning, EAP TLS could be a way easier method because all EAP TLS needs to do is the client needs to come online and enroll to a certificate authority and get its own certificate. So that is definitely much more easier to implement when compared to manual provisioning. And I take back my words when I talk about EAP FAST versus EAP TLS. And one more thing, this could also be an issue if you're looking to implement different inner authentication protocols because Cisco only supports EAP GTC as its inner authentication protocol. So this kind of limits your options to just one protocol. And although EAP supports various options like a username password combination or secure token combination, it still kind of narrows down your approach where, say, if you want to use EAP TLS as your inner authentication protocol, Cisco Gear wouldn't allow it. So that's one of the other things that you have to watch out for. All right, this has been a pretty fun video and I've had a lot of fun making it. And we've talked about a lot of concepts regarding EAP FAST. We talked about what EAP FAST was all about, the authentication credential that it used, which was known as the PAC. We also talked about the different phases of EAP FAST, the optional phase 0, mandatory phase 1, and phase 2. Then we had a look at the bad side of EAP FAST and why or what you need to watch out for when you're implementing EAP FAST in your network. I've had a lot of fun making this video. Thanks a lot for watching. For more information, please check out www.tacklist.com for all your wireless training needs. Thank you and have a nice day.